Hello everyone, this is Chandrasekhar here. Welcome back to the Kubernetes Zero to Hero series. In our previous sessions, we learned pods, replica sets, deployments. If you haven't watched those videos yet, I highly recommend checking out the previous sessions before continuing. Today we are going to learn two very important workload types. The first one will be stateful set and second will be daemon sets. By the end of the session, you will understand when deployments are enough or not enough, what deployments solve or what daemon sets solve. We'll see the real world examples of both stateful set and daemon set, and we will see the practical implementation using Kubernetes as well. So let's get started. We have learned deployments. Let's think of some front-end applications, for example, Netflix front-end, Amazon front-end, Flipkart front-end, React applications, or Angular applications. In these applications, if one pod dies, for example, front-end ABC123, it dies. So if front-end ABC123 dies, then what Kubernetes does? Kubernetes creates some random front-end XYZ 789. Some random name Kubernetes gives and creates it. Do we actually care what pod Kubernetes is creating? No, we do not care because every front-end pod is identical. Any pod can serve the request pretty much in the same way. This type of application where the pod identity does not matter is called a stateless application. This is one type of application. Deployments are very much perfect for stateless application. Imagine some, let's talk about some examples. Imagine you have 10 customer support agent. One agent leaves. The company hires another agent. Do customers care about the employee number of the agent? No. Customers just need support. That's exactly how deployments work. The identity of a pod does not matter for a deployment where we create any stateless, which we use to create any stateless application. But what about databases? Let's think about some database type, for example, MySQL. And now I am talking about another type of application to which we call as stateful application. Let's talk about some database. Maybe the database type is, say, MySQL. Database is MySQL application. MySQL database application. Suppose when we created pods, it has created three different pods: MySQL 0, MySQL 1, and MySQL 2. These are database nodes. So it has created three different pods under this. One is MySQL 0, another is 1, another is 2. What these are? These three are three database nodes, three database pods. If for some reason MySQL 1 crashes, then what Kubernetes can do? Kubernetes, following the deployment practice, what it will do? It will create some MySQL and will give some random name. That is what we have seen in deployment set. While we were creating deployment, in case if any of the pod dies, then what it does, it gives some random name, MySQL XYZ 789, some random ID it allocates to pod, and it recreates it. It will do quite the same thing with MySQL also if we are creating MySQL as a deployment set. But is this a good practice? Will we be able to handle any of the application which is using MySQL database or any of the application of type MySQL database or database application in this way? No, we cannot, because database depends on identity. Other nodes, whichever application or whichever nodes are expecting database, they will database to come up exactly in the same way like it went down. If MySQL 0 went down, then MySQL 0 should only come up. It should not take any random ID associated to the pod. This is where another type of application, another type of deployment comes in, to which we call as stateful set. So to handle stateful application, the deployment or the object which Kubernetes offers is called stateful set. another very important object which Kubernetes offers. So in a very simple words, if I have to define stateful set, a stateful set creates pods with a stable identity. What stateful set does, it creates pod with a, it assigns pod something to which we call as stable identity. This is one of the very important thing which stateful set does. A very simple example, consider that if you have created three pods, maybe the three pods of type web 0, web 0, 1, 2, and in case if one web 1 crashes, if one web 1 crashes, then stateful set is going to create another pod with the same name, same identity, which will be web 1, which cannot happen in deployment set. What we learned in case of deployment set assigns some random ID to any pod which crashes and recreates. That is not acceptable in some stateful application, for which we need stateful set only. Now, even before we create stateful set, we need a service. Don't worry about understanding services right now. We are not covering Kubernetes networking in this module. Stateful sets require a service object. So we will just create one and use it. When we reach the services chapter, when we reach the services module, we will revisit. We will try to understand cluster IP, headless services, DNSs, service discovery, load balancing in much greater detail. But for now, in order to create stateful set, we need a service. And that is the reason we'll just create a service. And that service will be a headless service. So as usual, what I've done, I pushed all the manifest file here in GitHub repository. You can anytime come here, fork it and use it. So this is the manifest file for headless service. It is also present in my machine. I'm going to use it. Where it is present here. Now let's go to this directory first. Let's go to this directory first. And as we come to this directory, next will be just to apply. We know the command kubectl apply -f, and that is headless service.yaml. Now, even before I do this, I'll come back here and I'll execute a command, the command which is needed to list down all the services kubectl get svc. As I've executed this command, it says I do have only one service, which is the default service which was created when we installed Kubernetes cluster IP. But don't worry about these services. Like the way I said, we'll try to understand this in huge detail when I'm covering the services module. For now, let's create one headless service, hit enter, and it says that service web created. Now, if I come back here and if I execute same command, it says another service which is with the name web has been created. So this is created. So now next thing what I will do is I will create a stateful set. Now let's try to understand stateful set bit in more detail. Now this is the manifest file for stateful set. In the stateful set, like deployment set, we do have API version, we do have kind, and this time kind is different from deployment. In deployment, we wrote kind as deployment, like the way you can see here. In deployment, we wrote the kind as deployment only, but in this case, we are writing the kind as stateful set, which is different. Again, metadata contains the name of the deployment, and specification again contains replicas. One more thing which I've added is service name. The headless service which I have created, I'm putting the same name here under specification. Again, selector, again template. This is the pod template, like the way we learned in deployment. So if anyone did not yet complete the topic of deployment, please go back in this Kubernetes Zero to Hero series and complete it. Again, another thing is about the Kubernetes definition, which contains the name of the Kubernetes and the name of the container and the image which is needed to create the container. That's it. Now we will use this to create a stateful set. Now let's create a stateful set and let's see what wonder stateful set is capable of doing. In order to create, I'm going to execute the command kubectl apply -f and stateful set. And as I hit enter, it says that cube stateful set the web has been configured. Now, in order to list it, what I'll do, let's execute the command kubectl get stateful sets and hit enter. It says that stateful set with the name web has been created. Now I'll execute the command kubectl get pods, and what I see is these are the three pod which has been created. These are the three pod which is a part of stateful set web has been created, which is with the name web 0, web 1, web 2. I kept both deployment and stateful set together so that you can understand the difference. See the name of the deployment. The name of the deployment contains some random ID, but the name of the stateful set is very much stable. Web 0, web 1, web 2. Now, this is the first thing which you need to notice. The pod names for a stateful set is predictable. Deployments generate random names here, but stateful set generate stable names. Now let's see what happens in case if I try to delete any pod, what name it gets. So in order to show you that, I'll open some another terminal. I'm just opening another terminal here, and I'll execute the command. Let me just increase the font. Kubectl get pods hyphen w. W stands for watch. So as of now, you see, these are the three pods which is running. What are the pod names? Web 0, Web 1, Web 2. Now what I'm going to do, I will try to delete a pod which is Web 1. Now let's try to delete. I went to another terminal and I'm trying to delete the pod which is Web 1. Let's see what name it gets. Web kubectl delete pod, and the name of the pod is Web 1. Hit enter and let's come back here. So you see what it is doing? It has terminated web 1. Here you see it is trying to terminate web 1. Termination completed here. Now again it tried to create web 1 only. It did not give any random name. It did not assign any name like web random 123 or web xyz 818789. It did not assign any random name, but stateful set has preserved the identity of this pod. This is the biggest feature of stateful set. Consider your company has three database servers, database 0, database 1, and database 2. Application know these servers by name. If database 1 crashes, we don't want Kubernetes to create a database with some random names. Instead, we need database 1 only to come back as database 1 with the same identity, with the same name. This is exactly what stateful set provide. Now, stateful set has similar type of features like deployment. We can scale it up, we can scale it down. Let's try to scale it up. In order to scale it up, again we will execute same command like the way we executed for deployments, which is kubectl scale, and we'll say stateful set and give the name of the stateful set as web, and say replicas equals to, as of now it's 3, we'll give name as 5. Hit enter and now come back here. What it is trying to do, you see what it is trying to do, it has tried to create another two pods web 3. So web 0, web 1, web 2 was already there. It has tried to create two more pod, web 3 and web 4. It is again like the way I said, its pod names are very much predictable in case of stateful set. So web 0, web 1, web 2, web 3 and web 4. Now we do have 5 replicas, 5 pod in stateful set. Now we can scale it down like the way we have scaled down our pods in deployment set. We can scale it down also, and if I scaled it down, as I scaled it down, it gives me, it has reduced the pod in reverse order this time. So in order to scale down, removing a pod happens always in a reverse order. Again, this is very different from deployments. Deployments can delete any random pods, but here it's removing only in a reverse order. So where we will use this stateful set. Remember, this stateful set will be used for any of the application which is stateful, which is not stateless. So it can be used in any of the database. It can be used in MySQL database. It can be used in MySQL database, Postgres database, any of the Postgres SQL database, any of the database type which you can think about. Let it be MongoDB, let it be Redis, let it be Kafka, Elasticsearch, Zookeeper, any of the application, any of the database type of application, any of the application which needs identity to be preserved, we will use stateful set only. Now, let's transition to DaemonSet and let's try to understand what DaemonSet is. Let's look at another problem. So the first problem which you have understood was we have to preserve the identity of an application. Now, another problem which IT industry faces is, consider you do have three nodes. As of now, let's see how many nodes we do have. kubectl, kubectl, get nodes. And I do have two worker node, worker 1 and worker 2, and one is a control plane. Now I do have two worker node, and what I want is I want one monitoring agent to be present on every node in order to ensure that the node is healthy. Can a deployment guarantee that your node is healthy? No. A deployment can only guarantee the number of pods by using replicas section, but it does not guarantee where they run, which nodes they are running, or the nodes are healthy or not. Every production Kubernetes node usually runs some monitoring agent like Datadog agent, Splunk, Fluentd, Prometheus node exporter, some security agent, some logging agent it runs in order to ensure that the nodes in the Kubernetes cluster is healthy. Why it does? It does because every node needs some sort of monitoring. Every node generates some sort of logs. Also, it needs some sort of security scanning. This is the place where DaemonSet helps us. So in very, very simple words, what is DaemonSet? DaemonSet ensures that monitoring is done properly. So what DaemonSet does? DaemonSet, DaemonSet, what it does? It ensures that monitoring is done properly. And how monitoring will be done properly? Monitoring will be done properly by ensuring one pod runs on every node. On every node of your cluster, it will ensure that one pod is running so that it can monitor every node properly. Now, in our case, we do have two worker nodes, worker 1 and worker 2. Now, pod will run in both the nodes. Exactly one pod will run on each of the node. So this is the main purpose of DaemonSet. DaemonSet ensures that the monitoring is happening properly. Now let's create a DaemonSet. In order to create a DaemonSet, again, we do have a manifest file. I have pushed the manifest file already there in GitHub. So you just have to run this. So this is the DaemonSet. Let's apply it. kubectl. Again, to apply, I'll execute kubectl apply, kubectl apply -f DaemonSet. And a DaemonSet has been created. Like the way you can see it, DaemonSet has been created. And in order to list down, again, let's come back to our terminal, kubectl get DaemonSets. As I hit enter, it says the daemon set, which is with the name Nginx daemon, is created exactly with the same name like the way it's there in my manifest file. Again, the manifest file of daemon set is very much similar to either deployment or stateful set. It is having API version, same API version, kind, metadata. Metadata contains name, selector, template, and specification. Same name which I gave to daemon set, it has created a daemon set with the same name, which is Nginx daemon. But what is the use of this daemon set? Remember, this daemon set ensures that there is only one pod running in every node. Here we did not mention any specific in any replica count. If you can see, under specification we used to maintain replica count, but here we did not maintain any replica count. Here automatically, as we are creating daemon set type of object, automatically it will assign one pod per node. In order to create daemon sets, let's execute the command kubectl apply -f and daemonset.yaml. This is the file which we do have, and it says daemon set has been created. So now let's see in our terminal if it has created a daemon set or not. Let's see if it has created. Yes, it has created daemon sets. Let's see what it has done with the pod. Now the main idea behind daemon set is not to create multiple replicas of the pod, rather than that to have one pod present in every node which is present in our cluster. Now, as we already know that we do have two worker node in our cluster, let's see if it has created one pod each node or not. Let's see. So kubectl get pods -o wide. If I say this, then it has created two pods, and each pod is created 48 seconds ago just now, and it's created in both the worker nodes. So now we do have two worker nodes, it has created in both the worker nodes. So in case in future if I do have three worker nodes, it will be created in three different worker node itself. So that is the idea behind having a daemon set. So what is the real world production examples of daemon set? Let's talk about that. In real time scenario, in real time production scenario, we use it with Prometheus node exporter, whose main purpose is to collect CPU or to collect memory and disk metrics. This is very much important because every node needs monitoring, which is a part of our Kubernetes cluster. It can be used with some other tools like FluentD also. The main purpose of FluentD is to collect logs. Now every node generates some logs, and with FluentD we'll be able to capture log, and DaemonSet is going to help there as well with some Datadog agent which is primarily used for monitoring purpose. Every node must report metrics, spikes, which is very much needed to capture proper monitoring configurations. It is used with Falco also. Falco is a security monitoring tool whose main purpose is to ensure that every node is protected. And for that also we need a daemon set. So this is the idea behind a daemon set. So now a quick summary on what we learned today. We have learned deployment. We got some idea about deployment, stateful set, and daemon set. So now the main idea behind, the main goal behind deployment is to maintain desired number of pods. It could be front-end applications, it could be APIs, microservices. Pod identity does not matter when we talk about deployment. When we talk about stateful set, it the main idea behind stateful set is to maintain pods with stable identities, and examples could be some database applications. So the applications which requires a stable identity like MySQL database, Kafka, MongoDB, it could be PostgreSQL. Pod identity is very much important in case of stateful set. When we talk about daemon set, it ensures that there is one pod on every node. Some examples which we saw: Falco, Datadog, FluentD. Here pod identity is not important, but what is important in this case is node placement. Every pod must be there in each of the node. There are plenty of questions which comes out of deployment, stateful set, and daemon set, such as which resource should I use for front-end application? Deployment, so simple. Which resource should I use for MySQL? Definitely it's going to be stateful set, because SQL is something which requires a stable identity. Which resource should I use for Prometheus node exporter? Now we already have seen it earlier. It is going to be a daemon set. Now, if the question comes such as which workload guarantees one pod per node, then again you will know it's a direct answer. It's going to be daemon set only. Some of the very important questions which can be asked in an interview is this, which we discussed just a few minutes back. So thank you everyone for watching my this session, my this video. In case if you did not subscribe the channel, please subscribe it so that you remain updated with all the upcoming videos. Also share it with others also.